Welcome back everyone to another episode of the Doom series, and in this video we are going to make some substantial improvements to our rendering engine and also fix a couple of issues. So to begin, I'm going to go ahead and inside of our main file, we are going to main directory, we are going to open up the mesh.h and mesh.c file. The reason we are opening these up is because now we need to add light. So for lighting we cannot use uniforms anymore since we have got meshes. Well, technically we could use uniforms, still it would work, but later on I'd like to merge all of the different meshes into a single mesh, and then it will get a lot more difficult to actually use uniforms. So a much better way to do this would be to kind of have it like this. So currently you can see I've got a type destruct vertex here. So inside of this struct we will also have a float light, and when setting the mesh we are going to have another attrib array, and we are going to this is going to be at the 4 array, and we are going to configure this to light. And of course this is not going to use GL vertex attrib I pointer, just a standard GL vertex attrib pointer, because it's just a single float, not a integer or anything. So we are going to have it like that, and inside of render.c we are going to at the location 4 we are going to take a float light as an input, and then we are also going to give a float light as an output. This is of course not going to be flat, so we're going to have just out float light, and in fragment shader we are going to have an in float called light. And in here I've changed something a bit. So for example, we have got a vector 3 here called color, and we just set this color here according to the different type of textures that we have and everything. And after setting the color, in the end we set the fragment color, the one that actually going to be rendered. We take this color, which is a vector 3, we multiply it by light, and we set the alpha value to always 1, not 0. We set the alpha value always to 1, and then we convert that to a vector 4 and just return that. And of course this is the multiplication step, which is what actually applies the light. So now I'm going to open up engine.c, and here I have made the most changes. So first of all, I have removed the scaling, because that was just complicating things a bit. You had to take scaling into account whenever doing anything, whether the vertices were scaled or not. Instead we are going to just change our OpenGL way we are doing stuff to kind of make it so that we can use the word coordinates directly from the WOD file. So now the speed, instead of being 5, is 500, which is a lot more appropriate. And another thing is that we don't have the scale macro here anymore or anything, and I've also removed any unused functions from here, and we have also removed the quad mesh since we don't need that anymore, we are not using it. And now when we are initializing our engine, we set the camera position to 300 instead of just 3. And the other thing is that when setting the projection, we make sure that the far plane is at 10,000, because the plane at 1,000 means that nothing will be rendered. So that is very important. And another thing you would notice is that we have got another variable here, which is the sky flat. Now this is the actual index of the flat representing the sky texture, and we get that by finding the f_sky1, which is the sky in the shareware version. We find that lump, and we subtract from that lump our start lump, and we subtract 1, just like we were doing if you remember from the flat loading video. So we get it the sky flat, and you might be wondering why we need the sky flat. Well, we'll understand the reason for that in a second, so bear with me, and let's go down here. And the other thing you will notice is that now we are no longer doing any scaling calculation. So we are not dividing these positions by scale, for example, and in here you can see that we are setting its position y to sector floor and sector ceiling directly instead of doing anything else. And here we are setting the actual light level. So we set the floor vertices light level to the ceiling vertices light level, the same thing, and we set both of them to the sectors light level divided by 256. And that's pretty awesome. So now let's go down, and you can see that in here where we are earlier scaling the points, we are no longer doing that, and we are specifying the light here. We just get the front sector's light level divided by 256, because light levels in Doom go up to 256, so we're gonna just divide that by 256 to get the correct level. And here I'm going to go here as well. You can see here I'm no longer doing the scaling, and we pretty much have the same light level logic. If we are doing one-sided walls, then we similarly use the light level and do not do any scaling. So that's all pretty good. And if I go ahead and go up here, just to illustrate this point to you, I'm going to change this to 1000. So if I change the far plane to 1000, you can see nothing renders, and if I keep moving forward, it starts to come into view. Now from a gameplay perspective, you can see that it's actually not that good. You can't see the outside of this place, so 1000 is clearly very low for this. However, something like 10,000 is a lot more appropriate. You still won't be able to see things that are very far away from you, but even at this distance you can see the map comfortably, like the whole of it's not being clipped. So, and at this distance the map starts to get clipped, so that means that we are going to have a pretty much it's going to work without any problems. You can try to increase it further, but then some things might break. I'm not sure. You can try it out if you want, but 10,000 is enough in my opinion. So I'm going to close this up, and there is one more problem that we need to solve. So while you can see that the lights are now working correctly, the places that are supposed to be bright are now bright. As you can see, these lights here or whatever, they are bright, and we have got these shadowish effects here, which are supposed to be handcrafted, and we have also got like this outer area that's bright, and then this is the dark inner area. Then we have got this lit area, and all of the lights are where they are supposed to be, and it's looking quite well. However, there is one problem. So if I go to an outside area like this one, you can see that we are having some walls here. Now these seem kind of weird because underneath them you can see there's no ceiling, so they look kind of wrong. So the thing is that in Doom it is necessary to change the height of the sector. So in this map the designers wanted to change the actual height of the wall, height of the ceiling for this sector, because we wanted this wall to be drawn lower. However, we do not want to change the sky texture. Now if we change the like height of this sector, then that means that this wall gets drawn. So that's kind of wrong. We don't want this wall to be drawn, we only want to change the height. So how do we do that? Now the Doom engine kind of uses a hack for this. So we don't we just kind of hack it together. The basic idea is that we check if for any line depth that we are drawing, if it's two-sided, when we are drawing the ceiling part, we check if the back sector and the front sector both have the sky texture. If they both have the sky texture, then we assume that this is supposed to be just a ceiling height change, and we don't want any wall drawn, so the ceiling is not drawn at that place. So in order to do this, we are going to I'm gonna go ahead and go to the place where we are generating the meshes. Here you can see that here we are handling our two-sided line depth, and we are going to ignore the floor part, instead go to the ceiling one. Now inside of this you can see we are doing all of this. We are going to I'm going to paste, actually not paste, we are going to go here and we are going to add an if condition. Now for this we are going to get our front sector. We are going to check if its ceiling texture is equal to the sky texture and sky flat. That's the reason we needed the sky flat, because we need to check if it is equal. And we are also going to check for the back texture actually, and so we are going to make sure that the back sector ceiling texture is also equal to sky flat. And if both of these are equal, then that means that well, we have got both sides are sky textures. That means this wall should not be drawn. So how are we gonna ignore this wall? Well, we could just not add the draw node, and that would be better, I guess. And that's actually what we are gonna do. So we are going to go ahead and take this. Here we are setting our draw node. You can see we do all of that. So if that's the case, then we are going to just do continue here, which means we are going to move on to the next part without drawing the ceiling node. So if I go ahead and run this, you can see that now the outside part, this wall is no longer drawn and it looks correct. So that means that well, we have pretty much got a working system here, and everything is drawn correctly. Of course, no actual sky is being drawn, that is for a future video, but the incorrect walls are now being removed. So yeah, that's pretty awesome, and that's going to be pretty much it for this video, and I'll see you in the next one, in which we are going to fix a small bug in our texture loading code so that we can you get finished with all of this texturing stuff and then move on to sky and then perhaps sprites, so in-game sprites and that kind of stuff. So stay tuned for that. Make sure to like and subscribe and share this video with other people as well, and I'll see you in the next one. And